All right, everyone. We are now going to take a look at VSEPR. And VSEPR is an acronym that you will see in reference to valence shell electron pair repulsion. And using this theory, you'll be able to determine the shape of a particular compound as well as the angle that those bonds make. And that's all based on the type of electronegativity that is pushing those atoms that are bonded to a central atom as far away as it can possibly go. Uh, the item we will be focusing on today is going to be the compound that contains oxygen and fluorine, so OF2. And before we get into that, I would like for you to take a moment and pause the screen and take down these 4 questions that you see here. Okay? Question number 1: how many things are around the central atom? Number 2: what structure is this molecule based on? 3: which atoms are replaced by lone electron pairs? And number 4: what is the final shape and angle? So go ahead, take a moment now, pause, and write down these 4 questions because they will walk you through obtaining exactly what shape and angle your compound is making. All right, awesome. So let's go ahead now and we are going to work on obtaining the information for the compound here. All right. All right. So the compound in question is OF2. The first thing we want to do is to create the Lewis dot structure for this compound. And in doing so, we'll be able to notice what items are going to be surrounding this central atom, which will help you to answer your first set of questions. So here we're going to look and see that we have 1 oxygen and 2 fluorines. So we are going to say that oxygen is going to be our central atom. And we know for oxygen, if we take a look at our periodic table, we'll be able to see how many valence electrons oxygen actually has. And oxygen has 6 valence electrons. Okay, so we're going to keep that in the back of our head. We also know that we're going to be bonding this oxygen with 2 fluorines. Okay, and we also know that fluorine has 7 valence electrons. So let's go ahead and place those now. So we're going to place our fluorine valence electrons and then come back and place our oxygen valence electrons. So we have 7 for fluorine. So we're going to start here and I'm going to work my way counterclockwise on this first fluorine. So there's 1, 2, 3, 4, 5, 6, and 7. Okay, we're going to do the same thing with the fluorine on the right, but I'm going to go clockwise around this one. Okay, so we've got 1, 2, 3, 4, 5, 6, and 7. So now we know that since oxygen is our central atom, fluorine needs to bond with that oxygen. And oxygen has 6 valence electrons. So we're going to go ahead and say that we know it's going to share an electron on either side with our fluorine. And we're also going to have a pair of electrons on the top and bottom. So if we were to count, we have 1, 2, 3, 4, 5, and 6. But we also know that if we have a bonding of 2 atoms, we are going to have a straight bond or a single bond created between those 2 atoms. So we would go in and actually replace our 2 dots with a bond there in the center. Okay, so give me just one moment. So we will replace this bond between the fluorine and oxygen here. And we will also replace it here. So those 2 dots will now become a single bond between these 2 atoms in our compound. Okay? So there we have our Lewis dot structure for OF2. So now we can begin to answer the questions that were presented in our first portion. So number 1 asks us how many things are around our central atom. So I try to remind people that the central atom is someone who is going to the store. They are going to the store and actually need to place everything that they have around them in a bag to carry out. So we know our oxygen here is our central atom. If I needed to put the 2 things in my hands in a bag, I would have a fluorine around my central atom. I have a fluorine around my central atom. And I also have 1 lone electron pair and a second lone electron pair. So in other words, I would typically tell students, you're having difficulty, draw some bags around those items and say, I know if I walked out of the store, I'd have this fluorine in a bag, I'd have this fluorine here in a bag, and then I've got a pair, so I think about a pair of shoes in a bag, and then I've got a second pair. So all together, I have 4 things surrounding my central atom because 1 pair of lone electron pairs accounts for an item. So we have 4 items around that central atom. Okay? All right, question number 2. Ask us, what structure is this molecule based on? So whatever textbook you're using, and for this particular session, the students are able to reference table 8.6, so chapter 8, table 6, and it actually gives you the list of the different items. And the item or the particular shape that has 4 things around it is called tetrahedral. So tetra for 4, okay? So we have 4 items around this central atom. And a tetrahedral structure is one that's based on having a central atom, and you have 4 things, as I stated, bonded to that central atom. And this dotted line just means it is in the background there of everything else we have. And then here, because in VSEPR, we're really dealing typically with atoms bonded to other atoms. So it is based on anything, regardless of if it's a pair of lone electrons, or if it's an atom. It is an item, and it's around that central atom. So there's my central atom, and there are the 4 things that would typically be there if we're dealing with just atoms. So now number 3 asks us, of these four things that would typically be bonded to a central atom that is tetrahedral, how many of those atoms are replaced by lone electron pairs? And if we look closely, we know we have a fluorine and a fluorine, and not two other atoms, but we have two lone electron pairs. So there's one pair and two pairs, okay? So we have two pairs that have replaced atoms, okay? So now that means that we are dealing now with a structure that looks more like this. Because this bond here and this bond here is now going to be replaced with those lone electron pairs. Okay, and we're still going to have our two fluorines bonded because these electron pairs are going to try to push those two atoms of fluorine as far away from oxygen as possible. So the negatively charged electrons on the top are pushing those bonds down, and the lone electron pairs on the bottom are trying to push those as far away and far up. So we would refer back to that same information, and we would know that a compound that has two lone electron pairs that was originally based on a tetrahedral structure is going to actually be a bent structure. And the angle for a bent structure is approximately 105 degrees. So please make sure that you take note of the four questions and then go back and try this again. Always remembering to reference your textbook so that you're able to follow along and know exactly what shapes and angles are available. Thank you and happy studying.